adding and subtracting fraction. Alright, very simple idea. Very simple idea. This is what I want you to write. Write this down as a rule. To add or subtract fractions, if the denominators are not the same, we have to find a LCD. So to add or subtract fractions, when the denominators are not the same, we have to find a LCD. Now, remember this. If you have two fractions, half plus half, you can look at it from two perspectives. Half plus half will give you 1, right? We know this from a practical standpoint. Thinking about a real example, half a pizza plus half a pizza will give you 1 whole pizza. However, using maths, whenever you're given fractions, we must ensure that the denominators are the same. And when the denominators are the same, we add the numerators. That's 2 over 2, which equals to 1. Right? So that's the rule, even when you're subtracting. Right? Half minus half is equal to 0. How do we get that? It's because the denominators are the same, I can subtract the numerators, so that gives me 0 over 2, which is equal to 0. Right? So that's what you need to remember. So the rule here is basically, if the denominators are not the same, when you're adding or subtracting fractions, we have to find what we call the LCD. And what is LCD? Write this down in brackets. So LCD is the lowest common denominator. And if we're looking at this here, the lowest common denominator, this is what we have to understand. I'm going to link this to everything that we've learned thus far. You see, LCD is basically, and I want you to write this in brackets, LCD is the LCM for denominators. This is why we do this, because if the denominators are not the same and if I have to find the LCD, then basically I look at what the denominators are and I'm finding the LCM. Why are we doing that? To make both denominators the same. This is what we are doing, right? This is why we do this entire process, is because we are trying to make both the denominators the same. So let's look at an example, right? Let's discuss some steps so that we have the necessary tools to solve a question when the denominators are not the same. So let's look at an example like 1 over 2 plus 1 over 3. Alright, so firstly I noticed two things. The first thing that I notice is that the denominators are not the same. So therefore I have to find the LCD, or I have to find the LCM for denominators. Okay, so now that's what I have to do. So that's step 1. So step 1 is LCD. How do we do this? We've already discussed this at length. Remember, we said that the LCD is the LCM for denominators. So therefore, we're just basically finding the LCM for 2 and 3. So how would I do that? I'll have 2 and 3. 2 is a prime number, so it can only be 2. And 3 is a prime number, it can only be 3. So these are the prime factorization for 2. And this is the prime factorization for 3. To find the LCM, what do we do? The LCM between 2 and 3. The LCM between 2 and 3 is found, or the LCM between any two numbers is found by multiplying the shared factors by the unshared factors. In this case, we have no shared factors, but we do have unshared factors, which will be the 2 and the 3, because it stands on its own. So therefore, it will just be 2 times 3, which is equal to 6. So that is what's the LCM between 2 and 3. In other words, what we're saying that the LCD is equal to 6. Now, this is where the second step comes in. This is what the second step is. Watch here. You see the 6 here? This is what I want you to call it. I want you to call the 6 the new denominator. So call this the new denominator. Why I'm calling it the new denominator is because we've found the denominator that is common between both 2 and 3. Right? I'm going to elaborate on this idea soon. Can you see the 2 and the 3? This is what we call the old denominator. Why is it called the old denominator? Because it was given in the question. Right. So watch here. This is the rule for step 2. It is new denominator over old denominator will give you what we call a factor. And we take this factor and we multiply it to the old fraction. Watch here. I'm going to explain it now in detail. You see, you have two fractions. So this is how I want you to structure your workout. You're going to say for the fraction 1 over 2, I will say new denominator, which is 6, over old denominator, which is 2, gives you 3. What do you do with this 3? You take this 3 and you multiply it by the old fraction. Which fraction? The fraction half. So you're going to multiply by the fraction half. However, if I just multiply by 3, I am changing the question. So what I need to do is I need to multiply by 3 over 3, because 3 over 3 is effectively 1. 1 times any number is just that number, so we are not changing anything. Let's do the step for the second fraction, 1 over 3. It'll be 6 over 3, which is equal to 2. What do you do with this 2? You multiply by the old fraction. I multiply by 2, but I cannot only multiply by 2, I have to multiply by 2 over 2, because I cannot change the question. I have to find a way to re-represent it so that it can enable us to simplify the question. So basically 1 times 3 is 3, and 2 times 3 is 6, plus 1 times 2 is 2, and 3 times 2 is 6. What did this entire 2 steps enable us to do? It enabled us to make the denominators the same. And the reason that was significant, and the reason we did step 2, is because all we did was, we found a way to re-express half, and we found a way to re-express 1 over 3, such that both the denominators are the same. Let me say that again. I found a way to re-express half, and I found a way to re-express 1 over 3, such that the denominators are the same. Because 1 over 2 is the same as 3 over 6. We did not change it. This is what we call equivalent fractions, something that I will discuss at the end of the video. And 2 over 6 is the same as 1 over 3. And this is why at the beginning, I think at the number systems module, I said the reason we write this equal to sign is because we are just re-expressing everything at the top. We are not changing it, we are re-expressing it. If I change the question, this is why you get things wrong, because you're changing the question. Here what we did was re-expressing it. And why did we re-express it? It's for one of two things. We're either trying to simplify or solve. Alright? And how does this enable us to simplify the question? It enables us to simplify the question because we are trying to add 2 fractions. That's what our aim is. Do you understand that? And now at the step here, because the denominators are the same, I can simply add the numerators, and 3 plus 2 is 5 over 6. And that's how you solve the question. Okay, so it's a very straightforward question, right? I'm going to do another example so that you can see how we do this. And yeah, it's basically as simple as that, right? Okay, so let's say we have 3 over 4 minus 1 over 6, right? Now, we are subtracting fractions where the denominators are not the same. So what do I have to do is I have to make the denominators the same. How do I make them the same? By following the steps that I discussed The LCD between 4 and 6 is basically the LCM between 4 and 6. 4 can be broken down into 2 times 2, and 6 can be broken down into 2 times 3. Right? Again, watch how I'm structuring it here. And remember, now we have to work a bit fast, so that's the reason why I'm not creating those columns like the column for 2 and 3. So now that we have the prime factors, what's the next step to find the LCM? We have to multiply shared factors by unshared factors. I think I used blue to represent the shared factors, and I used pink to represent the unshared factors. So this will be 2 times 2 times 3. This 2 represents the shared factors. This 2 and 3 represent the unshared factors. If I multiply them together, I get 2 times 2 times 3 is what? 2 times 2 times 3 is 4 times 3, which is 12. Very simple. So that's step 1 done. Let's do step 2. Step 2 is new denominator over old denominator, which gives you some number which is called the factor that we multiply by the old fraction. Right? Why are we doing this? We're trying to re-express both these fractions such that they have the same denominator. So if I look at this, and if I structure it out exactly as I taught you, then you would say for the fraction 3 over 4. So for the fraction 3 over 4, the new denominator is 12. The old denominator is 4. 12 over 4 is 3. What do you do with this 3? Multiply the old fraction by this 3. So I'll multiply by not just 3, but 3 over 3. For the fraction 1 over 6, I'll take the new denominator, which is 12, over the old denominator, which is 6. 12 over 6 gives you 2. What do you do with this 2? You multiply it by the old fraction. But you do not multiply by only 2, you multiply by 2 over 2. Because we cannot change the question, we have to re-express the question. Now if we expand this, 3 times 3 is 9. 4 times 3 is 12, minus 1 times 2 is 2, and 6 times 2 is 12. since the denominators are the same, I can simply add or subtract the numerators. But in this case, I have to subtract, so it'll be 9 minus 2. And 9 minus 2 is 7 over 12. And that's basically how you solve this question. Now, this is what I need you to understand, right? Again, you'd see I'm going to bring this quite frequently. Simplify, solve, and we want to do so in the best, fastest, and simplest way possible, right? I noticed something when I gave one of the students to solve this question. They made a mistake. They made a mistake when they found the LCD. Watch here. This is what they did, right? Let me show you, because you're going to learn a lot from this. Let me just keep both these approaches so you can see them. You're going to learn something very important, and it's going to link to this idea here. When I gave them 3 over 4 and I gave them 1 over 6, right? This is what they did. This is what they did. They messed up the LCM part. I think the number that they got was 24. I think they mistakenly added another 2. So you see here for the shared factor, instead of taking the one group, taking one of the 2, they took 2, so they multiplied by another 2 here. So they had 24. So it's fine. So they messed up the LCM part, 24. Right. Then for step 2, they followed step 2 correctly. So this is what they did. So they said, okay, 24. Then they said, okay, for 24, they said for the fraction 3 over 4. It'll be new denominator, which was 24, the incorrect answer that they had, over 4, which equals to 6. And they said for the fraction 1 over 6, it was 24 over 6, which is equal to 4. And then they multiplied the fraction. So they did all of this parts here correctly, right? So they said, okay, what we do with the 6, we multiply it by the whole fraction. What do we do with this 4? We multiply it by the whole fraction. Then they said, okay, 6 times 3 is what? 18. And 4 times 6 is 24. And then they said, okay, 1 times 4 is 4, and 6 times 4 is 24. Then, after this here, what can we do? Since the denominators are the same, I can go and subtract the numerators. So it'll be 14 over 24. But then there's something that we can do further. There's something else that we can do. You see, when you look at these 2 here, at this point here, you would think that you had the answer wrong. Because you got 14 over 24 and 7 over 2. And this is what I meant by doing things in the best, fastest, and simplest way possible. You see, at this point here, you just need to find a denominator that both these denominators can divide into evenly. You see 24, both 6 and 4 can divide into evenly. And you see 12, both 6 and 4 can divide into evenly. Okay, but between these two denominators, which is the lowest? Why are we looking for the lowest denominator? It's because of this reason here. Because if it's not the lowest, then you have to do an additional step in order to simplify this question. Because now if you watch here, you see 14 and 24 will simplify to 7 over 12. Why? Because 14 is actually 7 times 2 and 24 is actually 12 times 2. Since we have a common factor in both the numerator and the denominator, I can cancel and I'm left with 7 over 12. Can you see now that 7 over 12, both these answers are the same? Both these answers are the same now. But you wouldn't have seen it if you did not simplify further. So it is correct. It is correct. But I had to do one additional step. Why? Because I just did not find the smallest, the lowest denominator that is common to both the numbers. I found some denominator that is common to both, but it's not the lowest. And this is why if you did the more longer format way, you know when we did the LCM, for 4 we said it was, looking at the multiples of 4, it's 4, 8, 12, 16, 20, 24. And for 6, it's 6, 12, 18, 6, 12, 18, 24, 30. So here, 12, 12, 24, 24 are both common multiples between 6 and 4. However, which is the lowest? 12. So the aim is to get the denominators to be the same, and it must be divisible by both of the old denominators. However, it's better to find the denominator that is the same and the lowest. That is why we say lowest common denominator, because it comes from lowest common multiple. So 2 different ways to get the same answer. But what I'm saying is, if you get to the point where you just use some random denominator, right? But it's common between both these multiples, then you can solve the question. Okay, so I can even do this. Let's go a step further, right? Let's go a step further. So it'll be 4, 8, 12, 16, 20, 24, 28, 32, 36, 36 here as well. So if I look at this now, I can say, okay, 36 and 36 is a common denominator. Now watch here. 3 over 4 and 1 over 6. 3 over 4 and 1 over 6, right? So it'll be 3 over 4 minus 1 over 6. Right, remember I'm using 36 as my common denominator. Then what's going to happen, I'll say 36 divided by 4 is equal to 9. And so this is for the fraction 3 over 4. And for the fraction 1 over 6, I can say 36 divided by 6, which is equal to 6. What do we do with these numbers? We multiply them by the whole fraction. So multiply by 9 over 9 and multiply by 6 over 6. 9 times 3 is 9, 18, 27. 9 times 4 is 36. Minus 6 times 1 is 6. 6 times 6 is 36. Then we'll say 27 minus 6 is 21 over 36. And if you put this into the calculator, you get 7 over 12. 7 over 12. Same thing. Now I showed you an additional way to get the answer. Right? Can you see that? This is how you can actually find different ways to get to the same answer, but you just need to understand something, that we're trying to do it in the fastest and best way possible. Because C7, because you see 21 is actually 7 times 3, and 36 is actually 12 times 3. Since there's a common factor in both, we can simplify it further. However, if I just did the initial step where I found the lowest common multiple or the lowest common denominator, the lowest possible denominator that is common to both, then I do not have to do additional steps. This is why we work faster and we work efficiently when we do this, right? And yeah, so that's basically that for this part, right? And the rules will apply. Let me just elaborate on this. The rules will apply even if you have 3 fractions. So let's say you have 1 over 2 plus 3 over 4 minus 12 over 8. Right? How would you solve this? So now we're going to do step 1. Step 1, we're finding the LCD between what numbers? 2, 4, and 8. Right. 2 is broken down into 2. 4 prime factorized will be 2 times 2. And 8 prime factorized is 2 times 2 times 2. To find the LCM, we have to multiply shared factors by unshared factors. So this will be your shared factors. This will be a shared factor. This will be the unshared factor. So basically we have 2 times 2 times 2. These two 2's here are your shared factors, and this 1, 2 is your unshared factor. So therefore it'll be 8. Right, simple. Then for step 2, it's a new denominator over your old denominator. So let's do this now. So we have this here. For the fraction half, it'll be new denominator 8 over old denominator 2, which will be 4. What do we do with this 4? We multiply it by the old fraction. So we multiply by 4 over 4, because we cannot change the question, but we have to re-express. Then for the fraction 3 over 4, it will be 8 over 4, which is equal to 2. So then what do we do now here is we multiply by 2 over 2. And lastly, for the fraction 12 over 8, it will be 8 over 8, which is equal to 1. So we multiply by 1 over 1. Again, see, this way was unnecessary because the denominator is the same. So we cannot change or re-express the fraction with the same denominator. It will be that fraction. Understood? So now if we have to simplify, it will be 1 times 4 is 4. 2 times 4 is 8. Plus 3 times 2 is 6. Over 4 times 2 is 8. Minus 12 over 8. And now if we add and subtract the numerators, because the denominators are the same, it'll be 6 or 4 plus 6 minus 12, which is equal to minus 2 over 8. And that's a straightforward way of adding and subtracting fractions. In the next part of the video, we will discuss converting from mixed to improper fractions and from improper fractions to mixed fractions. And then we can move on to multiplying and dividing fractions.